Okay, here we are, video number 2 here, and again, I hope you're having a good summer so far, and I encourage you to please contact me through email if you haven't already, and you should be at least starting to look at the 3A worksheet, maybe parts of the 3A quiz and such as we roll through. I would space it out as we go through there, and remember that you can contact me through either email or through the comments on the videos, or I'll be at school about all June long. I've been there every day. I think I've had one day off since spring break, and I'll continue to be there if you need me up till about 3 o'clock each evening. But to here we're going to get to the root of this chapter 3, and we have rational and radical functions. So we're going to talk about rational function first, and I have a definition here for you. A rational function, as you can see, is a function r of x which looks like something being divided. Now the word rational is just an adjective which means like a ratio. That's what it means in math. When you think of ratio, you should think of fraction or comparison of two numbers. So anytime you see or think of a rational function, it's going to be typically a fraction. Now p of x and q of x are going to be polynomial functions. That means there's nothing unusual in there, like an absolute value or a radical or anything like that. And we often think of well, first, q of x cannot be 0, and that's an important point here. You can't divide by 0, and that's going to be an important point as we go through and simplify these things, that the top absolutely can be 0, the bottom, though, cannot. And anything that would make the bottom be 0, we've got to make mention of what we call excluded values, and we'll get to that here in just a moment. But we think of rational functions sometimes as big, ugly fraction. A big, ugly fraction. I'll make it plural here. Big, ugly fractions. And I'm going to give you an example of one of those right here. So we have this attractive looking thing, x squared minus 9 over x squared plus 7x plus 12. Now, the instructions here for one rational function, which again is a polynomial over a polynomial, the instruction for this particular one would be to simplify. Simplify. Okay? And when we think of simplify, there's going to be a very common mistake here. Some folks are going to think that you can just simply cross off these x squareds because they say, well, I've got one on top, one on bottom, so let me go ahead and cross those out. But that's not going to work here because you only cross things out when they stand alone as factors. And when they so-called cancel, they really don't go away. They just become 1. They divide to 1, and you don't have to write a 1 because multiplying by 1 does nothing. But when the x squareds are attached with a minus or a plus sign like these are, you can't just cross them out. As a matter of fact, a lot of times I'll say that pluses or minuses act sort of as glue. That for this x squared minus 9 as it is here, you can either cancel out all of it or none of it. You can't cross out part of it. So we absolutely cannot cross these x squareds off. What we're going to do here, I hope as you look at this, you're thinking factor, because the skill of factoring is going to be very much needed in this section. That's absolutely what we're going to do here. We're going to factor x squared minus 9. And in this video, I'm going to assume that you know how to factor. If you don't, you may want to go back and get some remediation on that. But x squared minus 9, as you remember, that's the difference of two squares pattern. That's going to be x plus 3 times x minus 3. And x squared plus 7x plus 12, that's a typical trinomial. We look for two numbers that multiply give us 12 but add to give us 7. Those numbers are going to be positive 3 and positive 4. And now you may notice, okay, I see something in common at the top and bottom, this x plus 3, and now since they are factors, since they're now separated from each other in a sense, x plus 3 and x minus 3 are separated, you can cross out the x plus 3. Okay? And they really don't go away. They just become 1, and 1 is unnecessary to write because when you divide something by itself, you get 1. The x and the 3 are okay, even with a plus sign to cross out, because you're crossing out the entire piece of the entire factor. So our answer here is going to be x minus 3 divided by x plus 4. Okay? x minus 3 divided by x plus 4. And again, you can't cross these x's out because this x is attached to the 3, this x is attached to the 4. You can't cross out part of it. Either it all goes or none of it goes. So this is my answer. But as mentioned earlier, we said the bottom can't be 0. So it's an important point here that we look for anything that would have made the bottom 0. So what would have made the denominator 0 here? Well, negative 3 would have, even though it canceled out, negative 3 would have made the original bottom be 0, and so would negative 4. So we make special note here, or a special note, that x cannot equal negative 3, that's this 3 here, not this 3, or negative 4. Because if it were either value, then the denominator would be 0, which would make this be undefined. Okay, we're now going to multiply a case, and here's where the calculator sometimes hurts us, as we sometimes lose sight of how to do common arithmetic operations like multiplying fractions. When you multiply two fractions, you're going to multiply straight across. Okay, 1 times 3 is 3, 2 times 4 is 8. So you multiply straight across. You do not multiply opposite corners. That's with a proportion. Now we're going to carry that over to rational functions. So let's look at something like this. Again, you have two rational functions, x minus 4 over x minus 5 times this rational function. Really, it's rational expressions here because I don't have the f of x present. But again, what we're going to do here is factor. Now, anything that has x to the first power that does not have a GCF, that's not going to factor. So I'm simply going to rewrite x minus 4 over x minus 5. But this will factor. And as a matter of fact, we want to say minus 20 there. That's a minus and not a plus. It's not going to factor if it were a plus. So it's a minus. Okay. So what are the factors of negative 20 that add to give you negative 1? Well, those are going to be negative 5 and positive 4. Again, multiply, give you negative 20, add to give you negative 1. The bottom right hand corner, what are two numbers that multiply, give you negative 24, but add to give you 2? Well, that's going to be positive 6 and negative 4. And remember, when you're multiplying fractions, you need to know the concept here, and the calculator doesn't help you for this. We're going to go straight across. So anything that is on top kind of goes together, anything on bottom goes together. But as far as cancellation, if we have anything on top and the same thing on bottom, they're going to cancel regardless of what fraction they're in. So in this particular one, the x minus 4s will cancel, as will the x minus 5s. Even though they're opposite fractions, opposite sides there, they're still going to cancel because one's on top and one's on bottom, and the tops and the bottoms just go together. So our answer here, our product, if you would, is going to be x plus 4 over x plus 6. Now remember, our excluded values is what's the fancy name of the values that would make the bottom be 0. We have to throw those out. So x in this particular example cannot be 5 or negative 6 or 4, because 5 would have made a 0 here, negative 6 would make a 0 here, and 4 would make a 0 here. And anything that makes the bottom be 0 anywhere in the fraction would have made the original problem be undefined, so we have to throw them out as excluded values.